welcome to another Bracebridge Engineering video. My name's Luke Parker, and in this video we're going to be talking about why my press tooling costs so much. It's a common topic, it pops up quite often, and it's something I wanted to go through and just explain a little bit about what goes into a press tool, why they do cost so much, and sort of the processes and stuff that are involved with that to try and help the customer ultimately in understanding what's going on with the tooling, why we need such precision tooling to make your parts, and a little bit more around that. I've got some notes down here that I'll refer to, but one of the things really we wanted to firstly point out is some tool makers, some press workers, sorry, do have their own in-house tooling and some don't. We don't. We only manufacture a small percentage of tooling, but we do all the repairs and all the maintenance of all our tools here. So we've probably got over about 200 plus tools on the shop floor, maybe more, and we repair and maintain all of those. So obviously capacity to do that it takes a lot of time, and to have your own press tooling shop means an awful lot of resources. And an awful lot of time and dedication to do that. I've got a tool with me. It's only a little one. Can't fit a big tool in the sales room, so I brought a little one with me. But the first thing really I wanted to discuss is what goes into a tool. Now, obviously, like I said, we're not tool makers predominantly here. We're in the business of making the parts. But I'll drag this over and I don't know whether you can see that, but I'll just hold each piece up. Now this is a little tool. Here's the base plate at the bottom, and there's the top part of the tool. Now, if we send an inquiry out to a tool maker, firstly, what they've got to do is look at your part and have a look at that, and then decide, right, how are we going to make this part? We sometimes give our sort of version, but obviously we always let the tool maker come up with their version. They've got to make it. So obviously the first part about it is really design. How are they going to make it? Somebody's got to design the tool, work out the number of operations to make the part, whether it needs single stage tooling or whether it can be done as a progression tool. Quite often a lot of tool makers use outside design and pattern maker tool design companies, or they've got their own in-house, but obviously that's a highly skilled job, so that's obviously something that has a lot of value attached to it, because if they get it wrong and the tool doesn't work, they're going to be the first people that get pulled up on it. So the first stage is design. What have I got in my notes there? And then after the design, obviously we've got to go and get some drawings made up, and quite often the drawings will be done as well by the designers. You'll have drawings to work to, so obviously the tool makers have got to work to some sort of drawings and tolerances and diagrams. So in this part, for instance, this is a little clip tool, top and bottom. You can see in there the little slugs in the bottom. So obviously all this would have to be drawn up. Now I'm holding this and showing you this because this is, on the scale, I think it'd be quite a cheap tool because of the size of it. Tooling can go up to many hundreds of thousands of pounds, especially even in the injection moulding world as well. The tools are absolutely enormous for some parts. So there is serious costs involved with that. So that's the second part, is obviously you need the drawings. Then you've got your materials that you need to order. Now obviously they're just not bog standard mild steel that you just throw together. A lot of these steels are tooling steels, so they involve more precision, more skill to make. They're not just everyday mild steel. You've got materials like D2 and Vanadis and all these. You can Google those if you want, and it'll give you a bit more an idea of what they are. But they're high strength tool steels which basically give high wear resistance. They're very machinable, and they're also heat treatable as well, because that's another component of tool making. So once you've got your drawings, you've ordered the materials, then obviously you've got to make them. So all of these parts on this part here, you've got your basic components inside, but you've also got a die set. Now all tools, really, we recommend that all tools go on a die set, and what they do, for those of you who don't know, is basically align the top and bottom tool together instead of having to align it in the press. And what that does is reduces setup times. It also reduces smash ups, because obviously if the setter doesn't line up the tools properly in the press and bring the press over, it will just smash the tools. So as you can see, I'll just hold that up, that you've got the top sleeves and the bottom pillars, and they sit on like that, and that guides the bottom and top tool. So that's a cost that has to go onto every tool. And you can start with several £100 up to several thousand pounds for a die set, depending on how big they are. Some die sets alone can be several 100 kilos just for the die set, and then obviously the tooling has to go on top of that. So there's a lot of materials involved here. I think this is marked up as D2. This is what called the snug, and that goes in the top of the press, which holds it in the top of the press. Then you've got all these parts inside, very high tolerance. We don't want burrs, and we don't want excessive play or anything in the tool, so they all have to be machined within a very high tolerance. Then of course you've got bought out parts as well. So these springs here, there's something that's not made by the tool maker, they'll be bought in, so there's extra cost in those. And as you can see, this is a very simple tool, very basic one-stage tool, and you're probably looking maybe a couple of thousand for this, depending on who you go to. Of course, you get cheap and expensive tool makers, like you do in any industry. So that sort of gives you a bit of an idea from the material side. Obviously, it's got to be machined, and then the wearing parts on the tool will also have to be hardened as well. We get what's sometimes called soft tooling. Now that's if you want to make a few parts. A lot of prototyping companies do soft tooling, and basically what that means is the tool's been roughed up in the lathe and made and machined and made, but not hardened. So if you make a design change or you want to move something or change a dimension, if it's possible with the tooling, then they can remachine it and then use it again. Whereas obviously if you harden everything and finish it, it's very difficult to then start machining that hardened part without serious tooling wear. So really you have to make again. But obviously all our parts for production, when you're making many thousands, you have to have the parts hardened. There's probably some other parts as well that I've not taken into account, but obviously as you can see there, it's not a straightforward process. A lot of people just think you can chuck a tool together in 5 minutes, and why does it cost several £1,000s? Well, it's an art, it's a skill. Some of the laws and rules around deep drawing especially dictates how you make them. You can't go from a large diameter blank to a small pot, long deep drawn pot. If you have a canister type part, you have to go through a series of operations, and of course every single one of those operations has to have a tool associated with it. So that sort of hopefully gives you an idea of what goes into a tool. Now another question that comes up is, okay, what can we do then to reduce the cost of the tool? Obviously for a tool maker, it's their source of income, it's their only source of income generally speaking. They don't make the parts, so obviously they've got to build a profit into their tool as well. They need to make money making the tools. So that's really their limitation. But in terms of reducing the costs, of course we can try another tool maker. Cheap doesn't always equal better. There are cheap tool makers, and sometimes there's a place for those. But what happens if we go for cheaper tooling sometimes is we get problems with the tool, inevitably, which then in hence doesn't help the customer, because then we have to have a break in production, we have to stop, we have to repair tools. So really there is no shortcut around spending money on the tool. With tooling, it does take commitment. If you've got a product and you want to get it to market and you know you need press tooling, it is a commitment. But once you have that commitment, once you've laid down the money for the tooling, it will technically be, for most instances, around for the lifetime of the job. It's only in very small circumstances where you've got such a high volume of parts that they're just wearing out and you've got to spend more money on only part of the tool. You're not going to have to replace the whole tool, because obviously not every part wears as quickly as the other parts. But generally, once you've got that tool, like I say, Bracebridge maintain that customer's tooling. So there is no ongoing problem or cost associated with the tooling. Once you've got it, you've got it. Other ways we can reduce the cost of the tooling is to look at the part. Now there may be some really tight radiuses, there may be a series of really tightly knitted holes or something that increases the cost of the tooling. There might be some really hard materials like titanium or some duplex stainless steels and things like that are very hard to work, which increases tooling wear. So some things you can look at is, can we reduce the radiuses to make them softer so the toolmaker doesn't have to make such a tight fit, or maybe an extra operation to counter for that. Can we reduce the number of holes or bends or anything in the part to make it simpler? And obviously the simpler the part, the cheaper the tooling, generally speaking. One thing, I'm just looking for my notes, one thing we can also do is how the part's made. So you can go from, perhaps this part for instance is a part that we'd make generally on a progression tool. But the volumes are low, therefore we've made this part in a series of conventional tools, which does make it a little bit harder. But obviously from a tooling point of view, it's very easy to make a tool that's excuse the editing there, my phone reached its maximum capacity on storage, so we'll carry on. Yeah, basically this is a conventional tool. We decided to make this one due to low volume. So instead of making a progression tool, which is more expensive due to the method of manufacture, a lot more goes into a progression tool, gas springs and all sorts of things. This one's a lot cheaper to make, so therefore the tooling was cheaper on this part. But obviously there's a trade-off then with the part cost, because obviously we've then got to manually handle each part through each stage, and that's labour and that's time, setup and all sorts. So that's obviously an extra cost on the part cost. So really there's a trade-off with everything. There is also another option as well, is using a different method of manufacture. We make a part at the moment that is a deep drawn can, and we've had all the holes and all the piercings in that laser cut instead. Now we could have made press tooling, which would have cost more to pierce out all the holes, but then obviously if the customer changed any of the hole positions or anything like that, there would have been quite a lot more cost involved. But with the laser cutting, we knew that there was a potential for that, but the laser cutter just enters a different set of values on their computer, and then the values are changed. So we've opted on that one, and that was a good saving in tooling for the customer. But like we said, obviously then there's a subcontract cost with laser cutting, which pumps the price up. So really, however you do it, there is always a trade-off. Whether you find a cheaper tool maker, it will come back to bite you, or whether you just use a different method, either your part cost will go up, or some factor will change, whether it's delivery times or something. So there's a few pointers. I hope that's been helpful. Maybe in future episodes we'll look to go and see a tool maker and maybe have a look on the shop floor, and actually go through the process of how the tool is actually made and get their side of it. That'd be quite interesting for a future video. As always, you can follow us on Twitter and social media. At BBE Pressings is our handle. Obviously on YouTube, LinkedIn as well. Hope you found this video interesting, and we'll see you again next week. Thank you all. Bye now.